Let's say you were given the equation e to the x plus x, and you want to find out when is it equal to 0. Solve it for 0. Good luck. And I'm not being funny, but good luck finding out. Unless you have a graphing calculator and you go, well, let me see. If I graph that, e to the x, where is e? Here we go. E to the x plus x. And I say graph it. And notice you can see what the picture looks like. If I zoom in on it, window, and I zoom in, I'll go from -2, it doesn't look like that far, to +2, and the y value from -3 to 3. I don't know, I'm just picking numbers. Let's see if I can zoom in. You can see where it crosses the x-axis, almost. Somewhere around what? It looks like about a half, right? And with these graphing calculators, you can actually ask the calculator to pinpoint that value. You can say, can you find out when is it equal to 0? I forgot where that is. And you can do the trace and trace it, but that's not a good way. But maybe calculate, second calc, let's see. Where is it equal to 0? See that button? Tell me when is it equal to 0. And it says what value? Oh, left boundary 0. Am I supposed to do something? Oh, I gotta pick the left boundary, I think. I gotta narrow it down. I gotta pick a value before it crosses. I'll use that number. And the right value, let me use another number. Right there. Hit enter again. Let it go through. -0.567143. You have to tell them where to search, because sometimes you have more than one answer. So you go before the point, you hit enter. You go after the point, you hit enter. Then you hit enter to tell them start calculating. Well, if I didn't have this calculator, then I got to do it using Newton's method. And basically what Newton's method is, pick any number, assume that's the answer. So you make a table, and it looks like this. I'll leave some space. I'm going to count how many times it's going to take to calculate that answer. I'm going to call this n, the counter. It's going to tell me how many times. That could take the whole page sometimes. We're going to start by taking a guess. We'll call it x of n. And I have no idea what number to use for this one, where to start with. So the book is actually kind to us. Says, you know what? When you're taking these derivatives, maybe you want to start with this. Maybe you want to start with that one. So let me start by using, I don't know. You saw where the answer, I thought, I'm going to start with -0.5. This is the first guess, basically. And let's see if that's a solution. Well, how do you know if that's a solution or not? You plug it in. You plug it into f of x. So let's go to f of x. Let's call this f of x. And let's find what is f of x is equal to. So when x is -0.5, you plug it in here, and you find the y value. What's that number equal to? -0.5. Oh, wait.
0.10653.
Set. Let me just do this 1 second.
I set it up the table.
Yeah, that's what I'm doing actually. I try to set the table here. So I'm going to put negative 0.5, and my answer is what? Oh, it's not bad. 0.10653. I want it to be 0, right? Is 0.1 close to 0? As well, it's close, but not that close. So that's not good. I need to figure another point. Well, it's not a guessing game. So Newton figured that out. It says, you know what? If that point doesn't work, then your next point should be, we'll go n plus 1, the next point. It should be whatever the previous one was, whatever you used for the previous one. You need to subtract from it f at xn divided by f prime of xn. That means I got to find the derivative now. What's the derivative e to the x? E to the x plus what's the derivative of x? 1. When x equals negative 0.5, what's the derivative of that then at that point? So let's take that point, negative 0.5, plug it in here. Okay. So here we go. Negative 0.5 plus 1. It's 1.60653. That's plenty. I'm not going to carry all these digits. Then I'm going to divide now. I'm going to find the answer to this little piece right here. What's f of x of n divided by f prime of x of n? I should have made that a little bit bigger. Divide this number by that number. 0.10653 divided by 1.60653. This is 0.06611. Good enough. Then my next value, I should test. So we realize this is not an answer. Negative 0.5 is not an answer. My next number should be the previous one minus f of x of n over the derivative of x of n. So the next number should be the negative 0.5, which is x of n, minus the answer from this. Or I use 5 or 6 here. 5. So my next number I'm going to be using in step 2 is not going to be, it's going to be the result of this, which is what? Negative 0.5663. I wish I left more space there. So let's see what that number is going to give me. Is that a solution? Plug it into f of x of n, into that one. Negative 0.5663. And I got 0.00132. That's almost a 0. If I said, well, I'm not really satisfied with that, I need to get closer, I'll continue. What's the derivative at that value? Plug this number into this one. Negative 0.5663 plus the 1, the derivative will give me a number of 1.56762. Divide this number by that number. This will be 0.000842. The next number I'm going to be using is going to be negative 0.5663 minus 0.000842. So the next number I'm going to be using, 3, is going to be the result of this, which is what? Negative 0.56714. Plug it into that one. Negative 0.56714. And my answer for this, ready for this? 0.0000052. Is that close enough to 0?
Yes.
Yes. I can stop. So that's my root. The problem is, if you guess the wrong value here, if you picked a 1, you could have 50 of these values. What's happening graphically, I'll make the function uglier than the one you saw there. Graphically, let's say you have a function like this. I just want you to see what's happening there. So this was not bad because that's an exponential function. It kept getting better and better. But what about if you have a function that looks a little bit strange there? It looks something like this. You know? You go, well, I'm going to use this value for a solution. You pick that number. What's going to happen is, we go, is this value a solution? Is this a 0? No, it's not. So how does the calculator figure out what the next number is? Draw a tangent line from that and see where it crosses. Oh, right here. So that becomes my second value. Let's use this one. Is this a solution? No, it's not. Draw a tangent line. A tangent line of that will look something like this. Is that a solution? Well, let me see. That's this value right there. Is that the solution? No, it's not. Draw a tangent line. And we'll be using a number down here to see if that's a solution. Where the problem comes in, what about if you hit one of these points right on the peak? What's the tangent line now? Tangent line is this line. This will never cross the x-axis. So you can go through about 10, 12 steps. You hit this point, it lands right there. If I did this better, I could have made it land right here. Pick that value. And then you go up, so that's my next point. Now let's find the tangent line. Uh-oh. Because what happens? What's the slope is the derivative. Isn't the slope the derivative? So the slope of this will be 0. The derivative is 0. Well, what happens if the derivative is 0? You're going to divide by 0, which you can't. So if you end up hitting one of these points, like this one, that one, we are in big trouble. We're going to start with a different point. So you could spend 5-10 minutes going through these points, going, oh, that doesn't work. I just divided, it says undefined. You can't divide by 0. You got to repeat the process with a different value. I'm making them like last like 4 or 5 tries before you get an answer, because the book is good to us. They go, use this as its starting points. They worked it through, because if they leave it up to us, we could be there for half an hour and go, that's not even getting closer. It's getting worse and worse by the minute. I'll just take an easy, not an easy, but I think a problem, just wild guess without thinking about it. Here's a problem. I said, well, we wrote something on the board today. What was it? Was it x to the 5th plus 5x squared? Let's say I'll make it plus 7 just to make my life easy. And I want to find the root of that. I want to find where the function is equal to 0. I need the derivative of that. Might as well find it right now. What's the derivative? 5x to the 4th plus what? 10x. And you're going to start with the point. So here we go. What do you want to start with? You're in charge of this problem. What do you want to use for a first point? Your guess is as good as mine. 12? No, you want to use 12? Okay. I have no idea what the answer is. He might be actually on the money. I couldn't tell you. So you want to do the 12? I'm going to start with a 12. I said, okay, let's start with a 12. You decide you want to begin the first value. It's 12. Well, is a 12 a solution? Let's take the 12, plug it into that. You can see it's going to be a humongous number. So that tells me maybe I shouldn't restart with a 12. Maybe I should do 1.2. I don't want to be here for 6 days. So let's begin with 1.2 instead of 12. But I mean, your guess is really as good as mine. I couldn't tell you what the answer to this is. I have no clue. I don't even know if I'm close to it or not. But I'll begin with a 1.2, because somebody says 12. I said, we'll do 1.2.
It'll have to be negative, whatever it is.
Well, yes. Well, so what you guessed on it. Let's see if it will work out. X to 5x squared. I don't know if it knows 5. I think I got to put 5 times x squared plus the 7. So I go to the table. I go, let's try 1.2. Yeah. 1.2 gave me an answer of 16.688. Notice this number is positive, right? You're adding 7 to it, that's a 9 already there. So if you pick a positive number, it's getting worse and worse because you're adding to it. I really should pick the negative number, but I'll leave it. I'll see what the math tells me. What's the derivative of x of n? Here we go. 5 times 1.2 to the power of 4 plus 10 times 1.2. The value is 22.368. The machine is going to quickly take me to the negative value, try to drag me back. Well, not quickly, but when I do f of x of n over the derivative, you divide this number by that number. 16.688 divided by 22.368. That number is what? 0.7461. That's plenty. Now the next number should be so the next number is going to be the 1.2 minus the 0.7461. Which is 0.45393. So my next number I'm going to be using 0.45393. 39, that's plenty. I'm running out of space here. But let's plug it in into the function. 0.4539. I got 8.0494. What's the derivative of that? 5 times, oh, blah, 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 blah. I'm in the wrong section, here we go. 5 times 0.4539 to the power of 4 plus 4.539. The derivative is 4.7512. Divide this by this. 8.0494 divided by 4.7512. 1.691. Now the next value is going to be the 0.4539 minus 1.6941. And I came up with what? Negative now. Notice how it took me to the negative. Negative 1.2403.
You just said negative
Negative 1.24. Oh. Negative. That's a negative. Negative 1.2403, right? So now let's see if that's a solution. Negative 1.2403. Uh-oh. That's 11.757. Not even close. What's the derivative of that? 5 times negative 1.2403 to the power of 4 minus 12.403. Negative 24.236. Divide them. Negative 0.4851. The next value is going to be negative 1.2403 minus a minus, which will make it a plus. So the next value we're going to be using is negative 0.7551. Negative 0.7551. Oh, it's 9 now. The derivative of that, 5 times negative 0.7551 to the power of 4 minus 7.551 the next value so to divide them, this is negative 1.0473. The next number is going to be negative 0.7551 minus a minus, that's plus 1.0473. So you can see you could be there for a long time. As I said, the book is kind to us. They'll tell us what to start with because they did some work on it in advance. They cheated there. So they know what number to use. That's only going to take you 2-3 tries at it. We know this is not going to be a solution. That's 7.429. And the derivative of that, I'll quit in a few minutes. I forgot to get out of this window. 5 times 0.2922 to the power of 4 plus 2.922. The derivative is 2.9584. That's a 2.5111, and the next number is going to be 0.2922 minus 2.5111. So on the sixth one, if this is not the answer, I'm still giving up. Negative 2.2189. Negative 2.2189. That's a negative 22, not even close. And keep on going.
So it actually gets you to 0 eventually?
Eventually we'll get you close to it, unless you hit one of those humps. So what you want to do actually in a case like this, you can write a computer program, ask the user to pick a starting point, and stop when the absolute value, because it could be plus or minus, when the absolute value of that answer is less than 0.00001. Then the machine will go through, oh, there's the answer. You know?
So is that what we're going to do?
No, I cheat on this one. I use my calculator. No. Now, actually, what they do for the homework is they give you a starting point, and that starting point, if you look at all the examples they did in the book, they don't last more than 2 or 3 steps, you know, because they chose the right number. Now, if I ask the machine to graph it and I picked a point around that, I'll be in good shape. So I could have eliminated some of that stuff. I could have went to this, I go graph it. Oh, look where the number is. Can you see it? Let me zoom in now. Let's zoom in, zoom out. Minus 10, or looks like about minus 2. I'll do minus 10 to 10. Looks like straight up in the air, huh? Let's do the y value again. The y value may be minus 50 to 50. Just to see, it looks like it's just going way up in the air. Oh, it can't. Here we go. Can you see the graph? So So I can see it's somewhere there. The x value, let me zoom in on the x value, minus 2 to 2. Let's see. Maybe I should have went even minus 3 or minus 4 even. So you can see where the answer is. Somewhere on what? Negative maybe 1.8. So instead of using 1.2, if I chose negative 1.8, it may be 3-4 steps I might get to the answer. Instead of picking a number. Well, we picked a number down there. So this is what's happening with that number, graphically again. And I'm exaggerating on the picture because it depends what you're graphing now. The graph looks like this. You know, I go, let me use this value as a point. That's the 1.2. That's what we chose. So that's not an answer. So what the machine did, it found the tangent line. Go, my next value. Let me go up there. Let me use this one. Well, that looks almost horizontal, doesn't it? Well, it looks like the tangent line will be somewhere down there. So I got to use that number down here. I'll fudge it a little bit there. I got to use that number. Oh, that's this point. Where's my answer? That's down here. Use that number now. That number, okay, is this my answer right there? Nope. What's the tangent line there? The tangent line here is this value. Now we come into the negative side. We say maybe this is my answer. Is it the answer? Let me see the height of it. Is that a 0? No, it's not. Where's the tangent line? Well, the tangent line is another horizontal line that goes down there. So you're going back and forth, zigzagging. Now, if I chose this number here, I said, let me try that one. It goes, well, let's see. Is that a solution? No. Tangent line, draw a line. Or maybe this point. Let's test that point. So you start to get closer and closer to it, much closer than if you pick just crazy numbers. So ideally, like if you want to cheat, you can look at the graph and say, it looks like somewhere around negative 1.5, negative 1.8. Let me start with that. You'll have a better chance to get to the answer quickly. And again, sometimes you have two answers. That's why they give you a set. Start with this. Because if the graph goes up and down, and just because you found one, that doesn't mean you're done. The graph might look like this. You find this solution, then you get two more. You got to go through. Once you find one answer, let's say I found a solution to that problem. What was that problem? The problem I use is x to the 5th and let's say I'll cheat here. I'll find the solution. Now I don't know if there's another solution or not. Give me a second here. You go through the math, you find out the answer, x is actually, it's negative 1.906. That's one of the solution, 906,208. You say, can you see if there's another one? Well, if this is one of the solution, that means this is a factor. X plus 1.906,208 is a factor. That means this one should be divisible by that. So if I use long division here, or synthetic division, to find what the rest of the problem now looks like, and redo the problem on the rest of the problem. There we go. I'm going to divide these two. X to the fifth, there's no fourth, I'll put 0x to the fourth. There's no cube, I'll put 0x to the third. I'll put 5x squared. There is no x's, 0x plus 7. I should be able to divide that by x plus, I'm going to cheat a little bit, I'm not going to write all these numbers. How about 9, 1? Just to make my life easy. What's x to the fifth divided by x? X to the fifth by x. X to the fourth. X to the fourth times x. X to the fifth plus x to the fourth times 1.96. 91 x to the fourth. Now you subtract these two. When you subtract, this is gone. 0 minus that, so you end up with negative 1.91 x to the fourth plus 0x to the third plus 5x squared plus 0x plus the 7. What is negative 1.91 x to the fourth divided by x? By only x. That's negative 1.91 x to the third. Multiply this times this, and multiply this times that. That will be a negative. What is 1.91 times 1.91? That's 3.6481 x to the third. Subtract them again. If you subtract, this is gone. What is 0 minus this? It's a negative 3.6481 x to the third plus 5x squared. Why did I pick that problem? Now divide this by x. That's a negative 3.6481 x squared. Multiply it by this. This will be a minus. I rounded up there. Times 1.91. 6.97 x squared. Now subtract them again. When you subtract, this is gone. What's 5 minus a minus? That's plus 11.97 x squared plus 0x plus 7. What's 11.97 x squared divided by x? Times this one. We have one more try after this. Times 1.91, 13.31. Subtract again. Zero minus, that's a negative 13.31x plus 7. Divide that by this. This will be a minus 25.4. Gone. And if this actually was a real solution, because I rounded up. If this was a real solution, guess what will happen here? What does this should be? It should be 0 if I carried all the digits. That number will end up being a 0. So it becomes this one times that. And if you want, you can try to simplify that piece again. Use Newton method, but do it on this one, not on the whole thing. Or pick a different starting point and see if you can find the other value. That's called long division, in case you forgot that. Before we get all these fancy calculators, that's how we did them. Every single problem. Now, I won't even do them this way if you put a gun to my head. I go, where's my calculator? Give me that calculator there. Give me Mathematica. Let me use a computer program. I'm not doing this by hand.